So I'll be talking about multi-cloud service mesh with Kuma. I've presented this talk at another meetup and it was almost an hour long, so I'll run through these slides without the demo. I'm Avinash. I work as a platform engineer at Platform A3, which is a platform engineering consulting firm. So that's about me. I spoke about the need for a service mesh. So the primary need for a service mesh is the network trouble that you come across with microservices. So when you have microservices, network is primarily unreliable. So in a microservice world, network is not really reliable. So there needs to be a way where you can make sure that all your requests go through and all of them succeed. So that's where the need for service meshes came around. I'll not really go into it in depth, but we have a certain wish list that we want a service mesh to solve. That is, we want to simplify service-to-service communication. So if you have in a microservice world, you want to be able to know where your other service is hosted and how do you communicate with it, and basically service discovery. And also you'll want to be able to simplify observability. So in a microservice world, gathering your observability data from all of the different services is going to be challenging. So you want a solution that will allow you to gather microservices observability data for you and simplify it. And of course, you also want it to be reliable. You want to make sure that your microservice is actually reliable and enhances security as well. I'll cover some of these aspects in the implementation that I'll be talking about today, that is Kuma. And finally, you also want to be able to increase your developer productivity. That is, your developers should not be worrying about all of these network issues. Rather, they should be able to focus on their application code. So this is where service mesh comes in. There are a lot of service meshes already in the market in the CNCF landscape as well. They primarily focus on three aspects: observability. So it gives you what is happening within your services, that is the network traffic that is flowing between your services. You'll be able to capture that and observe them over time as well. And also allow you to manage your traffic. That is, you can dictate where you want your services to communicate. That is, you can dictate whether service A can communicate with service B or not, and so on and so forth. These are some of the examples that I'm giving, but there are a lot more that you can achieve with a service mesh. And finally, security is another important aspect that service mesh brings in. That is, you can restrict, I spoke about restricting access as well. You can rate limit, you can enforce authentication authorization at an individual service level. And all of these can be done by offloading these to a service mesh rather than your application taking care of it. All right, so this is the service mesh implementation that I'll be talking about today. It is called Kuma. It is built by the folks at Kong. Kong is an open source API gateway, and there's a company behind it as well. So they've built a service mesh to complement their API gateway. And one of the exciting features about this service mesh is that you can deploy it just about anywhere. Most service meshes that you see in the CNCF landscape is for Kubernetes, but Kuma, you can deploy Kuma on bare metal VMs just about anywhere. It's just a binary that you run along with your application, so that makes it truly universal service mesh. And the proxies for the service mesh is based on Envoy, so it is once again lightweight and brings about all the benefits of using an Envoy as a proxy. It supports multiple protocols: HTTP, gRPC, TCP, UDP. All of it is supported. It's a standard one. And there are a few policies that you can apply to achieve some of the things that I spoke about earlier: rate limiting or traffic management or observability. All of these are achieved using various policies. Okay. The objective of this talk is to talk about multi-cloud service mesh with Kuma. So why do you want to do service mesh? I'll just briefly cover that. The primary reason is that you want reliability. That is, if one cloud provider goes down, you want to be able to rely on the other one. Or the primary reason that you would want to do is to avoid vendor lock-in, right? You don't want to depend on a particular cloud. So that's one of the primary reasons that you would do multi-cloud or multi-cluster for that matter. And you can scale better, and your performance is you can improve your performance by routing your traffic to the cluster that is closest to your user. So it can be in a different cloud or a different cluster. So this is how we achieve multi-cloud or multi-cluster service mesh in Kuma. Okay, we can just get the. Okay, I don't know how to get the pointer to work, but so let's talk about how do you achieve this? How do you achieve a multi-cloud service mesh? Setting up a service mesh in a single cluster is fairly straightforward. You ask Kuma to inject sidecars to all of your application containers. So a sidecar is basically the Envoy proxy that runs along with your service that takes care of all of these service mesh capabilities. That is, it will intercept your traffic before it actually reaches your service, and also intercepts the traffic that is living out of your service. And you can enforce all of the capabilities that I spoke about, rate limiting or security or traffic management. All of those capabilities are determined at the sidecar that is right next to your service. That is the data plane. And the control plane is where you define all of these policies. So your control plane is where your Kubernetes administrator or your infrastructure administrator indicates that you want to enforce these policies. And the control plane communicates these policies to the data plane where they're actually enforced. But in a multi-cloud environment or a multi-cluster environment, we have this concept called a global control plane that is responsible for communicating with all of the various clusters or cloud. So in Kuma, the cluster or cloud provider is abstracted as a zone. So in this particular diagram, we see there are two zones. So it actually simplifies it a lot compared to other service meshes where you can just define what a zone is. Can either encompass an entire cloud with various clusters or a single cluster. You define what a cluster is, and you define what a zone is. It is a single environment, and each zone has its own control plane that communicates with the global control plane. As an administrator, you talk to the global control plane that communicates all of the configuration changes to the zonal control planes. And these zonal control planes then proxies the configuration to the data planes in their respective zones. So this way you simplify your service mesh that is spread across multiple clusters and multiple cloud providers. You don't really have to worry about how your network is set up and a lot of other details that you'll have to typically care about. And another thing is each zone has its own zone egress and zone ingress. Any traffic that is leaving the zone always goes through the zone egress. So you can apply policies at the zone egress level as well. And any traffic that is coming into the zone is coming through the zone ingress. A zone ingress is mandatory for each zone, but zone egress is optional. So if you do not want a zone ingress, you can omit that. That way you enforce all of the capabilities or all of the policies at a zone level. So this is on a very high level, but this is how you would simplify multi-cloud or multi-cluster deployments with Kuma. And there are some reasons that you would want to avoid multi-mesh. Of course, it's the complexity of having to manage multiple clusters, multiple cloud providers, and the latency as well, because if the clusters that are spread across multiple regions are talking to each other, there's of course some latency, and the cost of having to run multiple clusters is obvious. But this also gives rise to a lot of opportunities. You can have a bounded context cluster per bounded context, as you would define in a microservice-based world. And you can do progressive app delivery. That is, you can upgrade one cluster at a time while still routing traffic to the other cluster. All of this can be achieved with a service mesh without having to actually define your routing rules at some load balancer level. You can do all of this as a policy in your service mesh. Right. Also, you can do disaster recovery natively. So that's a quick walkthrough on Kuma and how you can achieve multi-cloud service mesh with Kuma. Do you have any questions for me? And thank you, everyone. Hope you have an excellent rest of the day.